Hello, ladies and gentlemen. I just wanted to take a moment to explain this Phet simulation a little bit. Been getting a lot of questions just kind of about setting it up in general, and then a few questions on the worksheet as well. So I think for the most part, people are understanding the series part. Um, it's nice because as you see right here, it actually gives you a picture of what that series circuit should look like. So setting that up is pretty self-explanatory. When you're trying to measure the voltage or the current, it shows you exactly where to measure those, where to put the two leads, the red lead and the black lead. Um, and then for current, you're going to take this little crosshair thing and you're going to hover it over one of the wires. Um, and I'll show you that in a second here on the simulation as well. But you're just plugging in, you're going to measure for every one of these for the battery, bulb one, bulb two. You're going to measure, taking those two leads, you're going to measure the voltage across each of those. And then for the current, you're going to do the same thing for each bulb. You're just going to place this little crosshair right across one of the wires. And in a series circuit, it shouldn't matter. You should see that your current within a series circuit is going to be the exact same the entire time. Okay. And then from there, in order to figure out the resistance of each one of these, you can use Ohm's law, V equals IR, and then using that, you should be able to solve for your resistance. Okay, so you'd be taking your voltage and dividing it by your current. Okay, so moving on to the parallel one, just because it doesn't exactly show how to set this up, I have set up over here how you would go about setting this up. So we have, just like before, we have the battery, and then we have, as you can see, the charge flows into one path right here, this first path, and then the charge also flows into this second path over here. Okay, so now when you go to measure, let's just try measuring voltage. So I'm going to measure voltage first across the battery. So I'm going to hook the voltmeter up to each side, just like before, and we can see that it is 9 volts. Okay, and that should make sense because if I go ahead and I click on the battery, well, look at that. It is 9 volts. Okay, now I can do the same exact thing by taking my leads and putting them across this light bulb here. And what that's going to tell me is how many volts the light bulb is using. Now, I'm not going to have you worry about the negative on here. Just that just has to do with which way you have your leads. So depending on which way you have your black and your red leads, that will either make it negative or positive. So don't worry about that. You can just write it down as a positive value. So this light bulb is using 9 volts. Then we go over to this light bulb. You can see that this light bulb is also using 9 volts. Okay, so that's how you can measure the voltage when we're looking at solving for voltage across the battery, the light bulb 1 and 2. That's what I'm looking for you to do. Okay, so let's take this. I'm going to put this voltmeter away. Now let's take out this ammeter. Now ammeter, if you remember from your notes, your ammeter is going to measure current within a wire. Okay, now if I take this little, I call it a little circle with crosshairs, um, and I put that anywhere on the wire, it's going to show me the current running through the circuit at that point on the wire. So the current running through the outside here is 1.8. Okay, so like right here, it's 1.8. Well, then we get to this branch, okay, this first branch here, and now it's actually 0.9. Okay, so the current actually slows down here. And the reason the current slows down here is because we've added in this light bulb. And this light bulb has resistance. I can click on that and I can actually see that it has 10 ohms of resistance here. So that is why the current's going to slow down. Okay, and I go over here, this one is 0.9 as well. Right, so it's 0.9 the whole entire way till it gets back to the spot where there is no resistance on the wires again, and then it is back to 1.8. Okay, so that's how we can measure current and um, voltage. Now, what you can do is to figure out the resistance, you can either do one of two things. You can either take Ohm's law using V divided by I, or voltage divided by current to find the resistance, or you can go ahead and you can just click on the light bulbs and it will tell you the resistance of those. Okay. I also had a question about kind of comparing the series and the parallel circuits. When you go to compare those circuits, all I want you to do is just kind of tell me the difference between what happens to your current and what happens to your voltage if you when you have two light bulbs in series versus in parallel. So I'll do an example for voltage, for instance. Right now you can see that we said that each light bulb here was getting 9 volts. Okay, I put my ammeter on here and we can see each light bulb is getting 9 volts. Well, now if I go ahead and I'm going to cut this wire and I'm going to turn this back into just a regular series circuit. So I'm taking all that stuff off and now this is back to a series circuit. Okay, and actually I'm going to add in a second bulb just like we had before. So now instead of having a parallel circuit with 2 bulbs, now I'm going to have a series circuit with 2 bulbs. So I'll connect these, and when I go to put my voltmeter on here now, you can see that it's only getting 4.5 volts. So it's actually getting half of the voltage when they're in series versus when they're in parallel. And that's one of the advantages to parallel circuits, is when you have multiple pathways or multiple branches for that current to flow, light bulbs or other resistors are able to get more voltage. They're able to get the full amount of voltage from the battery versus when you have them in series. Now they're getting less voltage. And if I were to keep adding if I were to keep adding light bulbs to this series circuit, you would notice that the voltage would keep dropping for every single one. And these would get dimmer and dimmer. These little yellow lines here represent how bright that light bulb is. So you would see that those would start to get more dim and more dim the more light bulbs we had. If I were to keep adding light bulbs in parallel, and I added a second branch, a third branch, fourth, fifth, sixth, seventh, eighth, every single one of those light bulbs would be getting the full 9 volts of that battery. Okay? I hope this helped out a little bit to clear up a little bit of confusion. Please let me know if you have any additional questions. Thank you and have a great day.